Hi there, and let's have a quick look at this question. This is a mechanics where it's variable acceleration. Okay, let's read the question. The diagram shows velocity time graph, modeling velocity of a car as it approaches and drives through a residential area. The velocity of the car, v, at t seconds for the interval from 0 to 5 is modeled by this quadratic, where p, q, and r are constants. Now, it is given that the acceleration of the car is 0 when t equals 5. Well, you know it's 0 because now it's at constant velocity, and constant velocity means 0 acceleration, and the speed of the car remains constant. Okay, so determine the values of p, q, and r. Now, to get that, we need 3 facts because there's 3 unknowns. Now, the easiest one to do is this one here. This is when time is 0. I'm going to just put it here. When t is equal to 0, the velocity is going to be 18. Now, if I get this formula, and I say I've got v is equal to pt squared plus q t and plus r. Now in this case, when you put the velocity at 0, when time is 0, the velocity is going to be 18. Time is 0, so 0 times anything is 0, so that's gone. So time is 0, 0 times p, or 0 times anything is going to be 0, and you just left with r. Okay, so now you know r is 18, so we got 1 out. Done with that. The next time, what we can do is here, is we know when t is equal to 5, the velocity is going to equal 9. Okay, so let's just, we're done with that. So if I put, same in this equation here, if I put velocity is going to be 9, I'm just going to line this up first of all, and just clear that. Let's just put a line here, so we're done with that. So now, going back to this equation, this is the important equation here. So we know that the velocity is going to be 9 when t is 5. So if I put t is 5 there, that's going to be 5 squared, which is 25. So I'm going to get 25p. That is going to be 5, so that's going to be 5q. And we know that r is 18. Okay, so that's going to give me equation 1. I'm just going to leave that be at the moment because we can't do nothing there. We've got 1 equation, 2 unknowns, so we need another equation. Now, at this instant, it also told you, it didn't have to tell you that, it's helping you. It told you that the acceleration was 0. And then you should know that if you got your equation, v equals pt squared plus qt plus r, now you should know that the differential, the rate of change of velocity, the rate of change of velocity is acceleration, because the rate at which velocity changes is acceleration. Okay, the faster you go, that's accelerating. Rate is known as acceleration. So if we find this by differentiation, take the power down, take 1 of the power, you got to get 2pt, and take the power down, take 1 of the power, you got to get plus q. Okay, so you get a formula here, acceleration is equal to 2pt plus q. The r goes because there's no t associated with it, so when you differentiate a constant, it goes to 0. And if you want to see it as t to the power of 0, which is 1, when you differentiate that, take the power down, 0 times that will just go. Okay, so now we've got the acceleration formula here, and from here we can get our next equation, because we've been told that the acceleration is 0 when the time is 5. At 5 seconds it goes flat. Okay, the velocity is constant. So that will be t is 5. 5 times 2 is 10. So that's going to give me 10p. And that's going to be just q. Okay. So now what we get is two equations, two unknowns, and we can just do simple quadratic equations here. Not quadratic, simultaneous equations. So what you can do is, I'm going to say that to the other side. So I'm going to rewrite this. Let's rewrite the top, and I'm going to say, if I take that to the side, that gives me minus 18. So 9 minus 18 is minus 9, is equal to 25p plus 5q. Okay, so that's a rearrangement of equation 1. And if I solve these simultaneously, what I'm going to do before I start this simultaneously, actually, if I grab these two, so this is still my equation 2, and this is still my equation 1. My equation 2, I'm going to multiply everything by 5. Okay, so that's going to become 50. So I'm going to rewrite it here. 0 times 5 is, let me just write it in blue. 0 times 5 is 0. 10 times 5 is 50p. And 5 times q is 5q. Now the reason why I've done that is now the q's are the same. So I can just simply call this equation 3 and do equation 3. If I get equation 3 and take away equation 1, so equation 3 subtract equation 1, so minus 9 take away 0 take away minus 9, minus minus becomes positive, so that will end up as 9. Let me just write this in a different color. That's going to be 9. 50p take away 25p, so that's going to give me 25p. And 5q take away 5q is going to go. It's going to be no q's there. So therefore, p will equal, this is a 9 divided by 25, so you get 9 over 25. Okay, now if you got that, you can just sub it in any one of those. So I'm going to sub it back in because it's, just do it in this one because that's 0. So if I put 50, so sub in equation, sub that value in equation 3, that's going to equal 0. And you're going to get 50 times 50 over 25 is 2, so 2 times 9 is 18, plus 5q. And if you rearrange that, that becomes minus 18 divided by 5. So q, therefore q will equal minus 18 over 5. Okay, so now this equation here, you got the values of p, q, and r. You can rewrite that equals p is 9 over 25 t squared minus 18 over 5 q plus r is 18. Okay, so those are the values. Let's move on. Okay, just double checking that was over 25. Yeah, alright, done. So that one's done. 5 marks, happy. Calculate the distance travelled by the car from t equals 2 to t equals 10. So t equals 10 is here. And let's say 2 is here. Okay, and when we got this velocity time diagram, the area under the graph is the distance. So from between 5, because this is constant, okay, we can just do this as a rectangle. So that, take away that, is 5, and the height of this is 9. So basically 9 times 5 is going to give me 45 meters. Okay, so that's between there. And here, because this is got variable acceleration and it's a curve, you should know that the area under a curve is found by integration. So we need to integrate here. So we need to integrate this respect to t with those limits from 2 to 5. Now the beauty about this is your calculators. So this is part B. I'm going to write it different color, B. Actually, I'm going to line this up. From here. Okay. Cool. Right, let's carry on with this. So now I know that's 45, and the other area, which I'm going to just do from my calculator, I'm just going to plug it in. That's going to go, upper limit is 5, lower limit is 2. And we're going to integrate 9 over 25. Now on your calculator, it doesn't give you t, so you just put the x in that terms. But here it will be t minus 18 over 25 t. Okay. I don't know why I put q there. Can I just notice I put a q there? I should have read my bad. T minus 18. Oops, I'm using the wrong color there. Never mind. Anyway, actually, was it this one? Yeah. Okay. So that should have been 18 over 5, not 25. 18 over 5t, and yeah, and that's going to be minus 18. We're going to do that with respect to t. So if you put that in your calculator, which I'm going to quickly do, so make sure you know where your integration button is, and you put in 9 over 25 x squared minus 18 over 5x and minus 18. Then you put your limits in, which is 2 and 5. Your calculator will give you just 1 second. I just say I put a minus there. Well, I don't know why I put a minus. I'm going mad at the moment. So this is 18 is a positive. So you shouldn't get a negative value, which my calculator was giving me. So I'm going to go back and put positive 18 in there. Okay, now I press equals. Happy days. So now this is going to give me 30.24 meters. So then when it says here calculate the distance traveled between 2 and 5, so we need to add the 45 onto there. So the distance traveled is going to equal 45 meters. Add the 30.24, and that will give me 75.24 meters. Okay, sorry, I made a bit of a meal on there. I don't know what happened. That was a plus 18. I should have put a plus 18. Maybe when I was using the rubber, probably deleted it. Never mind. Job done. Just remember that. It's a good thing to see that anyway, because you shouldn't get the area negative. Negative area means that curve would have to be underneath this x-axis. Okay. Right. Hope that helps.